Today we're going to be talking about dilation. Dilation is a transformation where an object is enlarged or reduced using a scale factor. As you'll see, it's a lot like similar figures like we've been working with. This is kind of a real-life example of a dilation. We don't know the scale factor, but we could say that the smaller giraffe is a dilation of the larger one. Or if we want to, we could say the original and the bigger one is a dilation of the smaller one. Now let's look at how we could use dilation on a graph. As we look at this, we have a square labeled A, B, C, and D. The first thing we need to do is find the coordinates of those letters. A, as we can see, is 1, 1. B is 1, 3. C is 3, 3. And D is 3, 1. Now we want to dilate the shape by a factor of 3. All we have to do that is to multiply each coordinate by 3. So with A prime, we're going to multiply 1 times 3, get 3. 1 times 3 again, get 3. B prime, 1 times 3 is 3. 3 times 3 is 9. C prime, 3 times 3 is 9. 3 times 3 is 9 again. And then D prime, 3 times 3 is 9. 3 times 1 is 3. Now we graph our new coordinates. Go to 3, 3, 3, 9, 9, 9, and 9, 3. Now we have our new shape. Now let's look at the area of the two boxes. The first one is 2 units wide by 2 units high. The second object that we just regraphed that we dilated 1, 2, 3, 4, 5, 6. 6 high by 1, 2, 3, 4, 5, 6 wide. Now we can look at the area. The area of our original shape is 2 times 2, which would be 4 units squared. Our second shape, find area, we have 6 times 6, length times width, or height times width, is 36 units squared. So as you can see, even though we only dilated the shape by 3, you would think the area, you would just multiply it by 3. But actually you have to multiply it by 9 because you increased the width times 3 and the height times 3. So 3 times 3 would be 9. Let's look at another example. This one says to dilate the shape by a scale factor of 1/2. The first thing we have to do, once again, is to find all the coordinates of the shapes, of the points. A is at -6, 4. B is -6, 8. C is at 2, 8. And D is at 2, 4. Now we do the same thing, except this time we're multiplying by 1/2. So 1/2 of -6 would be -3. 1/2 of 4 would be 2. B prime, 1/2 of -6 would be -3. 1/2 of 8 would be 4. C prime, 1/2 of 2 would be 1, 1/2 of 8 would be 4, and 2, 4, B prime, 1/2 of 2 would be 1, 1/2 of 4 would be 2. Now we have to graph our new shape. -3, 2, -3, 4, 1, 4, and 1, 2. This is our new shape. Let's once again go back and look at the area of these two shapes. Our first one had a height of 1, 2, 3, 4, and a width of 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8, find the area, would be 32 units squared. Our second shape has a height of 2 and a width of 1, 2, 3, 4, which would give us an area of 8 units squared. Once again, we only dilated it by 1/2, but as you can see, there's a large difference. The area isn't just half of what the original shape was. Now let's look at finding scale factor of shapes that were dilated. We're going to say that the red shape is the original shape and the black shape was dilated. This is pretty simple. All you do is count the length of one of the sides. So we'll count this side over here, which corresponds to this side on the bigger shape. The small shape has a length of, or a height of 1, 2, 3. So we'll say original original 3. Now we can say that the new shape has a height of 1, 2, 3, 4, 5, 6. New is 6. Then we can look at the top. The top has a width of 1, 2, 3, 4, 5. Original is 5. Our new one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can say this has a scale factor of 10 over 5 or 6 over 3. Both of those equal 2. And it's important to remember this has a scale factor of 2 and it got bigger. One common mistake would be to put 5 over 10 or 3 over 6 and say that it has a scale factor of 1/2. You can tell if it's going to be a fraction or if it's going to be a whole number or a number bigger than 1. If it gets bigger, it's bigger than 1. If it gets smaller, then it's going to be a fraction. Here's a couple of problems to try for homework. In the first one, you have a triangle and you want to dilate it by a scale factor of 3. After you do that, you need to find what the difference is in the area of the two shapes. And remember that the area of a triangle is half the base times the height. In the second problem, you want to find what the scale factor of the dilation is if the red rectangle was the original. So the red rectangle is the original and it was dilated and became the black rectangle. So find the scale factor. Have a nice night.